Global Public Sector Partner Awards, Best COVID Solution, Palantir and NCATS. Great solution, great story. Most people think about, these kinds of research or nonprofits as a slow moving, standing stuff up, as Sam was saying, it takes time. You break it down by the time you get into things are over. This was agile. So take us through what made it agile, because that's not normal. I mean, that's not what you see normally. It's like, hey, we'll see you next year. We'll stand that up at the data center.
Yeah, one of the reasons we were able to move quickly was because rather than saying, oh, well, you have to provide the data in a certain format, a certain standard, N3C was able to say, actually, just give us the data how you have it, in whatever format is easiest for you, and we will take care of that process of actually transforming it into a single standard data model, converting all of the medical vocabularies, doing all of the data quality assessment that's needed to ensure that data is actually ready for research. And that was very much a collaborative endeavor. It was run out of a team based at Johns Hopkins University, but in collaboration with a broad range of researchers who were all adding their expertise. And what we were able to do was to provide the sort of the technical infrastructure for taking the transformation pipelines that are being developed, the actual logic and the code, and developing these very robust kind of centralized templates for that, that could be deployed just like software is deployed, have change management, have upgrades and downgrades and version control and change logs, so that we can roll that out across a large number of sites in a very robust way, very quickly. So that's sort of that's one aspect of it. And then there was a bunch of really interesting challenges along the way that, again, a very broad collaborative team of researchers worked on. And an example of that would be unit harmonization and inference. So really simple things like when a lab result arrives, we talked about data quality, you would expect it to have a unit, right? Like if you're reporting somebody's weight, you probably want to know if it's in kilograms or if it's in pounds. But we found that a very significant proportion of the time, the unit was actually missing in the EHR record. And so unless you can actually get that back, that becomes useless. And so an approach was developed because we had data across 60 or more different sites. You have a large number of lab tests that do have the correct units, and you can look at the data distributions and decide how likely is it that this missing unit is actually kilograms or pounds, and save a huge portion of these labs. So, that's just an example of something that has enabled research to happen.
What time savings do you think that saves? I mean, I can imagine just on the data cleaning side, that's just a massive time savings, just to infer, okay, based on the data sampling, this is kilograms or pounds.
Exactly. I mean, so we're talking, there's more than 3.5 billion lab records in this database now. So if you were trying to do this manually, it would take you thousands of years, so it just wouldn't be possible.
It would be a black hole in the data set, essentially, because there's no way it would get done. Okay.
You think from a systems perspective is, the Palantir, this environment, the N3C environment belongs to the government, but the N3C, the entire program, I would say, belongs to the community, and we have co-governance on this. So who decides really is just a mixture between the folks on NCATS, but not just NCATS, there's folks at NCATS, folks at, NIH proper, but also folks at other government agencies, but also the academic communities and these mixed governance teams that actually set the stage for all of this. And again, who's going to decide the standard? We decided we're going to do this in OMOP 5.3.1. Is the standard we're going to utilize. And then once the data is there, this is what gets exciting is then they have the different domain teams where they can ask different research questions depending upon what has interest scientifically to them. And so really, we viewed this from the government's perspective as how do we build, again, the secure platform where we can enable the research, but we don't really want to dictate the research. I mean, the one criteria we did put is your research has to be COVID focused, right? Because very clearly in response to COVID. So you have to have a COVID focus, and then we have data use agreements, data use requests. We have entire governance committees that decide, is this research in scope? But we don't want to dictate the research types that the domain teams are bringing to the table.
Yeah, open science is a huge wave. I'm a big fan. I think that's got a lot of headroom because if you look at open source, what that's done to the software industry, it's amazing. And I think your federated ID comes in here. And Ben, if you guys could just talk through the federated ID, because I think that might enable and remove some of those structural blockers that might be out there in terms of, oh, you got to be affiliated with this or that, or a friend's got to invite you. But then you got privacy, access, and this federated ID. Not an easy thing. It's easy to say, but how do you tie that together? Because you want to enable frictionless ability to come in and contribute. At the same time, you want to have some policies around who's in and who's not.
If you go beyond authentication, you also then you need to have the access controls in place to say, yes, I know who this person is, but now what should they actually be able to see? And I think one of the really great things N3C has done is to be very rigorous about that. They have their governance rules that says you should be using the data for a certain purpose. You must go through a procedure so that the access committee approves that purpose. And then we need to make sure that you're actually doing the work that you said you were going to. And so before you can get your data back out of the system or your results out, you actually have to prove that those results are in line with the original stated purpose. And the infrastructure around that and having the access controls and the governance processes all working together in a seamless way so that it doesn't, as you say, increase the friction on the researcher and they can get access to the data for that appropriate purpose. That was a big component of what we've been building out with N3C.
You don't know who's coming in, you don't know where they're coming in from, and the churn is so high, you don't know, I mean, all this is happening, right? So you have to be prepared to provision and provide resource to a very lightweight access edge.
And really, I think what we're really building are these sustainable platforms that we want to actually grow and evolve based upon the research needs over time. And I think that was really a huge investment that both, again, NCATS has made, but NIH is going in a very similar direction. There's a substantial investment, made in these really impressive environments. How do we make sure they're sustainable for the long term? Again, we just went through this with COVID, but what's going to come next? What are the research questions that we need to answer? But also, open source is an incredibly important piece of this. I think Ben can speak to this in a second. All the harmonization work, all that effort, essentially this massive complex ETL process is in the N3C GitHub. So we believe, completely in the open source model.
Absolutely. And I mean, we, at Palantir have been huge proponents of reproducibility and openness in analyses and in science. And so everything done within the Foundry platform is done in open source languages like Python and R and SQL, and is exposed via open APIs and through Git repositories. So that, as Sam says, we've pushed all of that ETL code that was developed within the platform out to the NCATS GitHub, and the analysis code itself, being written in those various different languages, can also sort of easily be pulled out and made available for other researchers in the future. And I think what we've also seen is that within the data enclave, there's been an enormous amount of reuse across the different research projects. And so actually having that security in place and making it secure so that people can actually start to share with each other securely as well, and be very clear that although I'm sharing this, it's still within the range of the government's requirements, has meant that the research has really been accelerated because people have been able to build and stand on the shoulders of what earlier projects have done.
Okay, Ben, great stuff. 1,000 researchers, open source code on GitHub. Where do I sign up? I want to get involved. This is amazing.
We'll send you a link. Yeah, if you do a search on N3C, do a search on that, and it'll come up with a website hosted by the academic side, and it'll show you all the information of how you can actually connect. And John, you're welcome to come in. By all means.
Billions of rows of data being solved, great tech he's working on. Again, this is a great example of large scale. The modern era of solving problems is here. It's out in the open science. Sam, congratulations on your great success. Ben, award winners, you guys doing a great job. Great story. Thanks for sharing it here with us on theCUBE. Appreciate it.
Thank you, John.
Thanks for having us.